Good morning and thanks for joining me for a stream from Bit Repairs. It's Wayne here and we're going to have a little look at an iPhone X this morning. Sorry to everyone that it's been a while since I've done a video. The problem is we've been moving the office around. As you can see, it's all laid out completely different to how it was last time. Yeah, basically we've done all of the layout completely different, so I could give you a quick tour of the area, but it's a bit of a tip at the moment. Behind me I've just cleaned up this area where I'm going to be working. So yeah, basically this one's come in, so it's come in from a guy. Let's have a little look. There we go. I'll fold that over so you can't see anything else, and there we go. So on here, basically, it says, purchased from eBay, no power, unhappy face. So that's the customer's note that they've put in the package. So first things, right away, what's the first thing we do with these phones when it's no power? We stick it into the USB ammeter. So let's stick it on charge. Let's go here, we'll plug it in, bing. What are we getting? What are we getting straight away? So we're getting 0.007, but you'll see that typical sign where it just pulses for a split second, just pulses up and shows you a higher current. Now what that's doing, that's the phone attempting to take on power. So basically it's sitting there, all the MOSFETs are powered off, and then it's suddenly going, right, let's try and power this thing on. Let's have a look and see what happens. The pulsing on, it's showing that it can't take anything. It's saying, basically, there's a short circuit beyond me. You don't want to power on because bad things are going to happen. And that's what it's doing. So that's why you see that pulse. Now, the only way you can see that pulse is by having a very, very fast USB ammeter, so you can see it immediately. The cheaper ones are just not going to do it. So you're going to get it so that you don't actually see the pulse, so it never actually appears as though it's attempted to boot. So anyway, let's have a little look. I won't go on about it. I need to open the shop in a bit and I've got stuff to do before I go off on holiday. So we are going to have a look at this. We're going to get it on get it off charge, because that's not going to do anything to this unit. Let's just get the base screws out and let's see what the fault could be. So we're going to have a look first of all, top layer, and then after we've looked at top layer, we're going to look in between the layers. So I probably better get my board splitter booted up so that it's preheated. Otherwise, we'll be sat around waiting for the preheater to work. So it's already been opened before the screen came off an absolute doddle. So someone's been inside this phone, which means that one of the first things we're going to look at is right next to where the NAND chip is. And I'm going to have a look next to the battery connector, because very often the problem you'll find with these is very simple. Someone's lifted the screen up. They've just not they've not lifted it enough around this area here, and they've damaged one of the caps next to the NAND. They've unplugged the battery, and when they've unplugged the battery, they've basically damaged one of the caps around there. So this whole thing is caused by a bad cap. Somewhere along the line, this phone is going to have a bad cap. I'm almost certain of it. So I have to take everything off very carefully so that I can be 100% sure that none of the damage is caused by me. You don't want to cause additional damage to this phone and then be unable to diagnose it. So we're going to go and switch over now. We've got the screen off it. We're going to look under the microscope now for the basics. So I'm going to switch to camera 2 and you'll be able to see here. Can I do picture in picture so you can see both? That one. On. There we go, you can see both now. So let's have a little look now. First of all, we're going to have a look right next to here. right next to the battery connector. I'm going to pull that battery connector away, and then we're going to have, can you all see that? Hold on a sec. I think we have a camera focus issue. Let's have a little look. So, let's have a little look. I just need to be able to see it on there. So if I can see it on there, then we need you to be able to see it perfectly at the same time there. Right, let me just screw that tight. There we go. Right, so you should be able to see the same as what I'm seeing now without it being blurred. Yes, you can. Look at that. Okay, so all I'm going to do, I'm going to pull this little bit of underfill away here. It looks like it's been charred up a bit. In fact, one thing I'm going to look at, has this board been separated before? Doesn't look like it. We've got no cut here between the two layers. It just looks like it's been heated up a bit because this underfill is all mushed up. So one of the most common things I see around here is we see this cap here right in the bottom next to the so that one there, yeah, that I'm just pointing at. You can just about see it. It's just under there, right next to the battery connector. So you're going to see that it's been knocked off the board sometimes. So that's not the case on this one. So let's carry on unplugging, carry on unplugging, carry on unplugging. We're just looking around. We're just going to have a look around before we even take the board out, before we even bother with anything else. We're going to look around for anything that looks a bit charred, a little bit not like it's supposed to be. They could be anywhere. If someone's had this open before, it's a lot more difficult than if it's a brand new, fresh, no one's been in here. So I'm going to pull this whole foam seal off because I want to see underneath it. I want to see what's going on. So all coming off now. I doubt anything's under here is wrong now looking at it. So I'm going to stick that foam on the side of my microscope. Let's have a little look through it together. So that's all okay. All that's okay. Nothing to see here. Nothing around there. Nothing there. So we're not seeing anything there, I don't think. That looks fine. All of these caps are looking absolutely fine. So we're going to go round and we're going to go down next to here. This one is the most common one I see problems with, right next to the NAND chip. People just scrape it with the side of the screen as they lift it up. Absolutely massively common, that is. So yeah, that looks like it's that board looks like it's okay. So I don't see anything on the top layer of the board, which is unfortunate because I could have just gone in and out quick fix and yeah, end the video. But alas, never mind. This shit is never usually so simple. So let's have a little look at pulling this connector off here. That's all off. Get that bit of foam off because otherwise it's just going to melt when I put it on the heat plate. Right, so let's switch back over to camera one. That's enough microscope now. I'm going to get my heat plate switched on now because I am almost sure I'm now going to have to split these boards. So let me just grab the cable for it around here. There we are. Right, now let's grab the plate. Which one is it? It's not that one. It's that one. Right, so we're just going to pull them off. Ding, ding, ding. Like that. Get the microscope to one side. There. Let's not get tangled up. That's plugging into there. And it's auto switched on. So that's all right. Now let's get the board out. Let's get the board out of this unit. We want to try and get this over and done with quick as possible. So let's get the screw out of here. Screwdriver's not magnetized. Try again. Right. And again. Screw down here. And a screw down here. Come on, out you come. Then we get the little plate off down in the corner. Little tiny piece. Don't miss that one out. Don't want to lose it. Then we get the SIM tray out. Simple simples. If you don't know what you're doing at this stage, then you really shouldn't be attempting this repair. Push the pin back in again. Come on, pin, go back in. There we go. Right, now let's try and lift the board out. There we are. Disconnect this one at the top. Ta-da! One board. Absolutely loving it how easy it is to get these boards out of these iPhone X's. I think the only easier one I've found is the 11. The 11 is really easy to get out. That is amazingly easy. Right, so I just need a screw off an iPhone 7 now. A base screw off the bottom of an iPhone 7. So I'm going to have a look in my little screw box. See what we can find. We're basically just after a base screw. If I can't find one, I will rob one off another phone and put it back in later. I've usually got screws hanging around from no fixes and just chassis replacements, just spare bits going around. It's always handy just to keep yourself a little spare bits box. Otherwise, you just get to a point where you need the odd tiny screw, the odd, just bits lying around. So let's just cut across here now. Just going to cut across there, so we want to make sure that when we lift it up, it just comes off clean. I know other people reball. I know a heck of a lot of people out there do actually reball the layers on this. I'm not one of those that actually does this reballing. So hold on a sec, we are having issues with the laptop. Laptop's having a moment. Fortunately, I don't use a laptop to stream with, otherwise that would have been a bit bad. I use the A10 Mini Pro, and for streaming it has been the single best thing ever. You just can't beat it. It literally does. Switch my multimeter over to continuity. Yeah, the A10 Mini, it literally just does all of your streaming needs. Connects everything together. You've got everything without another piece of hardware to rely on to fail. So literally all that does, that just goes straight from your camera, straight to the router. You hit go, and that's it. It's so simple to do. The only problem is the cost, obviously. You've got to have decent quality equipment. So you've got to have like a HDMI video camera, you've got to have a HDMI microscope camera. All these things cost money, and you don't really get a great deal from YouTube. Unless you're a massive channel, you're not going to be making mega bucks off YouTube videos. Right, anyway, blabbering on now. So what I'm going to do now is I'm going to see if this is ready. So I'm going to put the tweezers on, and I'm going to give it a bit of a wiggle. I'll secure it down actually, shall I? Otherwise we'll lift the bottom board up again. So let's give it a wiggle. Let's give it a wiggle. And I'm seeing the top layer moving independently of the bottom layer. So I'm going to lift now as quick as I can. There we go. Little puff of smoke. Okay. Right, so what we're going to do now, we're going to unplug this, right? And we're going to see if we've got a short on the battery line here. So I didn't test this beforehand. To be fair, I'm almost 100% sure there was one, so there was no point testing. So we're going to see if the short now is in the top of the bottom layer. So let's just go here, testing there, dead short, testing here. So there we go, we've got 300 ohms we have on the top layer board. So we do have a problem with this top layer board. Not as common as it is with the bottom layer. We do get a problem more often, I'd say, with the bottom layer. One thing I am going to do now that I completely forgot about on this is I'm going to check for long screw damage, because I've had this same fault now. I'm going to switch over to camera 2. I'm just going to see if there's any long screw damage here. So right next to the battery connector, nothing there. Then I'm going to look here. I've got a screw in there already, which I've just put in. They're the only two places really that it can be. So I'll just check the other side and see if anything's been popped off the board. No, because that chip would have been forced off the board if there was long screw damage there on that layer. So we're just going to have a look around now, and we're going to see if we can find any caps that look obviously bad. So we're just going to have a bit of a scout around. Let's have a little peek, see what we can see. Not seeing anything at the moment. Normally it shows up pretty quick. I'd say the bottom layer more often than not is the one where you can see the short almost immediately. You know, most of the time I have a look at it, I go, bing, there it is. I think I've done a couple of videos before now showing it. So, not seeing anything here. Let's just test again because the heat can make it look like there's a short as well. Now it's cooled down enough. So we're seeing a 477, 478. Usually means that's somewhere along the VCC lines. So let's just test around here now and let's see if we can find any shorts. So I'm going to put our probe on ground and we're just going to prod around. So we've got a short here down in this corner, right down there. So we need to have a look on ZXW now just to see what that cap does. So let me have a little look, see if I can show you along the way. I don't know if my laptop's going to behave now because it was going on and off before. Let me just see if it stays switched on. Okay, seems to be staying on at the moment. Right, I'm going to just tap here. Anyway, I've had a look. I know what the cap is. It is a VDD main one. Let me just show you on here. There we are. And I'm going to switch over to camera 4 so you can see it. And then the short is on this cap here. So that one there is on the VDD main line. So you can now see that the short definitely is on the VDD main line. So we're just going to have a look around now at what else is on that line. So let me switch you back over to camera 2 so you can see all the caps. I'm going to zoom in. There's quite a lot usually on this line. So top of the board, there's very little on that line. There is a couple underneath the shield here at the side. So this little shield here, there's a couple under there. Very rarely see them go wrong. It's very often on the back of the board here that the problem occurs. So we're going to have a quick scout around. We've got the areas we're looking at really. It's all around this PMIC. There's a lot of small caps around there. Then we've got around here. We've got this row of caps down here. And then we've got some other stuff around the opposite end, around the little dog leg of the board. So I'm going to look closely now. Now I know that it's on VDD main. You're going to zoom right the way in. And you're going to look for caps that are looking kind of a bit worse for wear. So let's look at this one that I tested to begin with. Looks okay on the side. It still could be that one, but it does look okay. That one looks okay, as does that one. Yep, they're all looking fine. This one here is on VDD main. That looks absolutely fine. So we're just scouting around. Let's see what we can see. Let's have a little look at all of these little mini caps around the PMIC. I've seen these go faulty before now. Not as common, but they all look absolutely fine as well. They're not on the VDD main line, so that's okay. Now let's have a little look across the other end of the board because we've inspected all of them. We're not seeing anything. This one's on VDD main. This little one right in the middle of the screen. It's in the middle of my screen, not in yours. That one there is on VDD main, but it looks fine. So now let's have a look around here. around the audio circuits and the camera circuits, Face ID, etc, etc. So we're just going to check around all these. Close as we can, let's get a good look at them all. Sorry about that, that's the air compressor going off. We'll just cut the power to that, shall we? Because that could be compressing for quite a while. Sorry about that. That was just the air compressor recompressing. We still need to make a little box for that outside. Carrying on along. I really can't see anything here at the moment that seems to be problematic. So yeah, we're all looking okay around here. Very unusual that you can't see one immediately. Just adds to a bit of a challenge for you to try and hunt it down. So I think with this, we're going to have to inject some voltage into this now, because I don't see anything obvious that's got in, you know, that's shorting. Like I say, I only spend half an hour per unit, so if I don't get to the bottom of this within half an hour, then I usually call that, you know, call that quits, because it's just not worth spending that much time on one device. So next thing I'm going to do, I'm going to have a little look around this connector, which one is it? J5700. There's a few caps there on the top of there that I can see. It's not worth ignoring them, just in case it is one of those. It might have been chipped by somebody. That might be what's causing it, you never know. So let's just have a little look on the top layer and just see these ones that we can easily have a little peek at. That one looks fine. That's not a cap, that one, but that is going to another circuit. Let's go into VMON, so no, I wouldn't be worried about that one. Let's go back over the other side. We have got a few little tiny caps along here, absolutely tiny. They don't appear to be a problem. So yeah, we're going to have to inject a bit of voltage into this. Let's get the bench power supply switched on. Switch you back to main camera. So we've got bench power supply switched on now, and we're just going to put a little bit of voltage into it now. Let's get all the screws out of the way, because I have a habit of knocking everything over, and then I've got to find where all the screws go then. So let's just put everything out the way now, and we're just going to get an X Flex, iPhone X. Going to plug it in. Okay. And on here we've got our voltage, 4.2 volts, current, 5.2. Let's lower that down a bit first. Let's inject some power, and we're on. We got straight away, we're pulling 4 amps. So let's see if we can feel some heat first straight away. Ow, bollocks. Yes, there's some heat around there. Sorry for the language. That was a little bit warm, that was. Let's just get a cotton bud on there. I've turned the current off straight away. I think I figured out roughly where it is. So all we need to do is, I'm just going to get some, not some acetone, that's not good. I'm going to get some IPA, a little squirty bottle. I'm going to put some current in again now. I'm not going to put quite as much in this time. I don't need that much because I'm feeling it straight away. So I'm going to lower it down to a couple of amps. And now let's see what we've got on a couple of amps. Let's zoom out of here. Go around these caps that we seen earlier. It's likely to be, at this stage, it's likely to be the PMIC that's showing that heat. I could be wrong. Not seeing anything around here immediately. What's it pulling now? So it's pulling 0.001 at the moment. Ah, that would be why. Because the battery connector's come unplugged as I was turning it around. So, let's try this one again, shall we? It's going to curse me, this phone, isn't it? Right, what are we on? Pulling full. Right, let's just see if we can see it. Right, so we can see straight away we've got some fizzling around there. We're going to turn that off now. There's no point carrying on. We're fizzling right around this little MOSFET here. See there? The problem we've got there is basically we'll just end up burning out that MOSFET there if we keep up with it, because it's not VCC main that's getting hot. It's VBAT pulling over to VCC main, trying to pull some current, and that MOSFET's just toasting itself. So we're going to have to get a little bit more into it with putting a current direct onto the VDD main line. So what we'll do now is we're going to leave the negative plugged in on the bench power supply. Okay, going to leave the negative one plugged in. I'm just going to pinch this cable down so that the board stays still. Okay, so we're going to unplug the positive, leave the negative plugged in, and now what I'm going to get is I'm going to get my my little pokey tool. Let's grab my pokey tool. Right, so down here, so what we've got around here, we've got this little multimeter probe with a needle point on the end. So we're going to plug that into the positive, right? So we're pulling negative through the cable, so I can power this back on again. I can power that, we should get no current draw, perfect. Right, now what I want to do is I want to make sure that I am injecting some voltage into this board, but not through a cap, because I don't know which cap it is that's faulty, so I don't want to go and put the multimeter probe onto one that could potentially be faulty. So what I'm going to do, I'm going to have a little look here at this little area in the corner. There's a big bunch of VDD main pins around here. So I'm going to go back to microscope view and I'll show you this little bunch of VDD main pins that are around here. There they are around there. So I'm going to put one probe on ground and I'm going to make sure they are all VDD main, because they're all shorting out. So should have a load of them around here. There we go. All of them scattered around there. Sorry, it's a bit blurred. It's blurred for me, but I didn't really care. There we go. So all of these are going to be VDD main. All of these ones. So what we're going to do, we're going to use one of these to try and figure out which cap is faulty. So what I'm going to do, I'm going to get my multimeter probe ready. I'm going to put it onto one of those, make sure that we're pulling some current, and then I'm going to squirt some IPA on the board so that we can see it straight away. So let's go like this. We're pulling our current. Let's see what gets hot. I'm not seeing anything immediately getting hot around here. I could just cheat and get the FLIR camera out, but I'm trying to do it for people that don't have a FLIR camera. This is your method. This is the way you're going to go about doing it. You know, you don't have to have hundreds and hundreds of pounds worth of equipment to try and diagnose these faults. You usually do just need a bench power supply, some multimeter probes. Put a bit more current in, we're not quite seeing it yet. This must be a really hard short, this. I'm not seeing anything showing up at the moment. So I'm giving up around this area of the board now, that I thought it might be to begin with. Moving over here. Okay, what I am seeing, right, can you see there? Just spotted that straight away, right? Can you see them bubbles coming out of the side of that cap? Hopefully you can see it's fizzling away nicely. That cap there, I think, is our fault. Or it's on the opposite side of that cap. That there, I am pretty damn sure, is going to be our faulty cap. So that is how you diagnose it without the need for a FLIR camera. That's your short by the looks of things. Right next to the CPU. So this cap ain't getting replaced, unfortunately. I'm really sorry about the people that do like to see everything back to how it was. But unfortunately, I've got a cap here right next to the CPU, and it's on a line with many caps. So if this is the faulty cap, I am so unlikely to be putting this one back on again because of the potential for damage. So I am going to heat up because it's underfilled. So I'm going to put some heat on first so that I can make sure that that underfill goes nice and soft before I try and chip it away. So we're going to put some heat on it now. Tiny bit of underfill just to the side. So I just want it to go goopy. So I don't want to damage anything. I don't want to damage the CPU trying to get this one component out. There we are. That's the one out. Just rolled it over to one side. So now what we're going to do is, let's get that cap, pull it off the board, put it on top of the CPU. I'm going to test it on its own and just see if it's shorting. So can you see that where I've put it? I've just left it on top of the CPU for now. So let's see if that cap is shorting, shall we? So let's have a little go here. There we go. One absolutely, completely and utterly shorting cap. And now I'm pretty damn sure. Let's take this off. Let's take it off the old life support. Let's put that cap in the never bin. Take it out of the grips. Switch it back over to camera 1. Take this off here. Take that off there. I would say the fix rate on these X's it's really high for these faults. It's so common do you find that it's a cap that's been shorted. So let's just test here. That's a short because that's ground. And then the other side, we're up to 2000 ohms. I don't know whether you can see that on the multimeter in the distance. But yeah, that to me is absolutely perfect. So what we're going to do now, we're going to get our board back again, the bottom half of it. Bring that back over here again. Okay. We're going to have a little look around just to see if we've got any dry bits on here, because if we've got any dry bits, we might want to add a little bit of flux on just to make sure. So let's just have a look at this board. Let's just see if there's any bits that have got any dry areas. I'm seeing a little bit around here. They're not looking particularly smart. That one's not. I just tap them up with a bit of flux, it just helps them. There is still a lot of flux from manufacturing on this board, which is what helps towards making it waterproof. Bit of that. Right, so what we're going to do now is going to get our power again for our board splitter. Squish it over there, slick you back on camera 1. So yeah, I'm off for a bit of a holiday now after this video, so you're not going to see another video for at least another week from me. But at least I'm happy to say that we're likely to have another fix here with this one. So let's go straight down here, straight in, get the board in nicely. We're still warming up. So bottom board's on, top board's on. Let's just take this screw out of the top board because the pressure plate doesn't go on if that's on there. Right, so it's warming up, is it? No, we've got dots, so we need to switch that off and back on again. Wonderful Chinese hardware. Absolutely amazing they are at coming up with these things, but bloody shocking quality. I don't know how they can come up with such amazing bits of kit, just shoddy quality. It just baffles me. But, you know, it works, it does the job. It's allowed me to separate the board, join it back together. I remember before I had this this board splitter, how difficult it was to try and get these boards apart and back together again. It was just a complete nightmare trying to do it. So we're warming up again now. We're at 133. You can see here, that's where it's coming up. Temperature's just rising up here. So we should have a nice fix on this today. I'll be happy with that. So we can turn that off, turn that one off there. Put our, basically as this is happening, you just start putting your tools away again. You know, it's nothing worse than when you're looking for your tools again and you can't find them purely because you've been lazy on the last job. So you need all of these tools. You need hundreds and hundreds of different tools for all of these jobs. But you don't need them all the time. You'll need them for very specific purposes. So if you are just getting into this, you will know that you'll need like a base set of tools and equipment. So your base set of tools and equipment, your irons down here, you don't need 2 irons, 3 irons. You know, I've got a micro pencil, a proper iron, micro tweezers. Then on top of that, you got your hot air, that's compulsory. You got your bench power supply, nothing like that is compulsory. You know, you really do not need a £900 bench power supply to get you started. However, they're really good if you're going to be doing it all the time because it makes your job easier. So anything to make your job easier when you're doing quantities, you just can't beat. So we're just going to get this on here. I'm going to put the plate on the top. You can see here, I'm just, there we go, I'll move the scope out of the way. I'm just getting the alignment on this now. I'm going to lower it down into place. There we are. Drop some compression. Bam, bam, bam. These are all on Union Repair, these. Hopefully they're still doing them. There we go, 187, 188. I already know it's melted at this temperature because I've seen the smoke starting to come off of it. So all I'm going to do now is I'm going to unplug the power to it. That's going to go to one side for a sec to cool down. And we can have a little look at the next job if you want to follow along with me. What's the time now? It's 18 minutes past 8. So that one there, unfortunately, it's going to have to stay in there for about 10 minutes till it's cooled down. So that goes on top of the job box. I could do with more of those actually, to be fair, because I found myself in a situation regularly where I'm doing 2 iPhone X's and I've only got 1 X board splitter. I do have this other one that Adam got me that we use for the shop stuff, which is the JC one. Whereabouts is it? Is it up here? Is it in there? Nope, not in there. You can see how often I use it because I don't know where it is. The only bonus with that one is it does iPhone 12. Yeah, I haven't got a clue where it is. So if you've not seen the JC one, it's just a bit more flimsy, not as high a quality. As, you know, if you can get high quality on these things, you're just not quite there. Yeah, so that's the problem I always find with them. You know, you can get these things, but some of it's shit quality. You just got to buy it all and then get rid of what's crap and keep what's good. What else am I using around here? You know, you've got your digital multimeter. I use the Rigol DM30580. So basically, that one's a bench multimeter. It's so much easier. I can't believe these people have been micro soldering for years, and they got one of these crappy little handheld multimeters that you're constantly having to power on, power off. Your probes are getting tangled around everywhere. The batteries are running out in it. Oh, it's bloody shocking. How can somebody get away with just using a cheap 20 quid multimeter when all you need is a really decent one? Shows you 5.5 digits. What else have we got around here? You've got your oscilloscope over in the corner over there. That hasn't been switched on for months. I have to say, micro soldering wise, using your oscilloscope is quite rare on older phones. Some of these newer phones, you are going to be using it a little bit more because the signals that you're going to have to read. So with your oscilloscope, you can read them signals, you can read the data lines and see if you're getting the data. It's like if you've got dodgy image. I diagnosed one the other day that had like a really funny screen, kind of artifacts going off on the screen. So I measured all of the circuits, all of the diode mode readings were fine. I had a little look at some of the data lines, and some of the data lines on the oscilloscope were showing poor readings. They were showing either no data, missing data. They were kind of transmitting every now and again. If you put pressure on it, it'd show you the data. Take the pressure off, it wouldn't. So these boards have got a lot of stress fracture places. You'll be seeing them where they're kind of you're having to scrape away all the underfill on the board, and as you're scraping away, so on these boards here, you know, you're scraping away the underfill around the edge of the components here, around these connectors, and you find that even at low temperature, the components are falling off at the same time. So that isn't that you're being heavy-handed, not usually. You know, if you're at a low temperature and you're being very diligent, it's not that. What it is you're going to find that the board has been stressed, and these bits are so bloody small that they just come loose and they become intermittent. So they're kind of in and out, in and out, in and out. And that's when you get the problem where you put pressure on a connector, it comes back again, take it off, goes off. And you think, oh, is it the FPC? No, it's the components, it's the supporting components around the FPC. So that can often be the issue. Right, we've got another one here. This is an XR. So this one has come in. Don't want to show any details. This has come on for unknown problem diagnosis and repair. I need to have a look at the order number on this one because there'll be some notes against it. There usually is anyway for them. So let's have a little look on the system. So what was the order number there? Let's get that order number, pull it up. It's asking me to log back in again. Right, logged back in again. So let's just see if we can find out, before we've even got the notes, what the problem is with this device. Let's plug it into power and let's see what we've got on the screen. We're getting 0.013 amps. Looks like we're not charging at the moment. Let's have a little look at the notes on here. So the notes that we've got is phone dropped, now won't take any power. So phone dropped, now won't take any power. Usually when you get a phone that's been dropped, I've said it once, I say it thousands of times, it's almost always a cap that's shorted. These MLCC caps do not like being dropped. They don't like that sudden shock to the system. So that, I would say, is likely to be another shorted cap. Again, we've just had it on the X. We're getting it again now with another one. I'd say the majority of the time, no powers, you are going to find that it is caused by these drops and the capacitor shorting. Let's see on this, as we're going in. We're not seeing anything here. Might have to warm this up. It looks like it's a brand new unopened unit. So careful, careful. Yeah, we're going to have to get a bit of heat on that now. Let's just turn the heat plate on. There's no point trying to force it. You know, it's a good screen. It's not smashed. We want to try and see if we can get to the bottom of it and what's going on. We're just getting 0.013. Sorry, we're going to have to wait for that heat plate to warm up now. Let's see if this has cooled down enough to take it out. Shouldn't be too bad now. Hopefully we can get back to this X and we can finalise everything on it. Try and get it back in its housing. So we're going to just take this off carefully. Right, now what we're going to do with it is move that scope to one side. And I'm just going to see if the top layer still has independence from the bottom layer. It doesn't. Right, good. So it's dried. We're all right. It's gone below the temperature of the low melt solder on the top layer. So we're good to take this board out now. Let's get our tweezers. I always lift up by the sim tray. Is my kind of go-to area. It's a nice area you can really grab at with your tweezers. Now I'm going to put it down on my bench, and that last bit of heat is just going to get sapped out of it now onto the bench. Pull it on me onto my heat plate. The heat plate's turned off at the moment, so it's just going to sap all of that extra heat out of it and straight into the heat plate. So what we're going to do now, we're going to get this board, put it back into here again. The way I like to do this is kind of sideways, give it a bit of a sidey action. There we go, slidey, slidey. Get it in. Come on. Let's get me tweezers. I always struggle with this little connector at the top there. Bit of an arse, that one. You've got to try and make sure here as well, try and be very careful that you don't get any of these flexes trapped underneath the board. So count along. You should have this bottom one, all of these, missing one there, one at the top, these three camera area. You know, you can find that that gets stuck in as well. This gets stuck under the board, this little antenna flex at the bottom. So we're pulling that out. Let's just reclip that back in again. Done. Let's put our connector on for the power at the bottom. And let's plug all of these in. Bing, bing, bang, bosh. There we are. Right, all in. All the connectors are back in again. Don't reconnect the battery. There's no point doing that till you've got the screen on. Right, so we're ready to plug the screen back in again now. Let's have a look at this. Screen looks okay. Not damaged by the looks of things. Always plug in at the top here. Always plug in the Face ID. So I flip the screen over to one side. Plug in your Face ID. Flip the screen back over again, and then we're going to plug in the top one, LCD connector. Then we're going to plug this on, your touch connector. There we go. Right, then we're going to plug power in, and then we're going to see what we get with our bench, not with our bench, with our power. So do we get Apple logo? Do we get Apple? Pulling nice current, nice current. Come on, what are we going to do? What are we going to do today? Not very happy today. Come on. Don't be showing me up, you damn thing. Looks like we may have something else on it. So we don't have a short... Oh, we don't have the battery plugged in, might be the issue. Pulling 0.4 amps. Let's unplug. We should have had Apple logo boot looping, actually, if the battery was unplugged. Should have been getting a boot loop on it. Let's just try holding power button down. So we're getting nothing on this at the moment. We're getting 0.4. So this looks like it could be DFU mode, this. That's quite a common reading to get when it's stuck in DFU mode. So there could be more wrong with this than just the initial fault. What I'm going to try now, I'm actually going to try a battery in this. I'm just going to go across to our batteries. I just need to take my microphone off for a sec because it's across the other side. Hold on a sec. There we go. So we got battery for iPhone X. Let's stick the mic back on again. Some of you are probably thinking, why didn't he test it with the top layer? You know, just after that cap had been removed, just test it, just top layer only. You can sometimes, but generally, if you've sat there, you've found your faulty cap, and you're going to try and attempt a boot after that, then generally after you've found your faulty cap, that's it, that's problem solved. So I'm going to try now just plugging a battery into this and see what happens. So this is one of our test batteries. Do we get Apple logo with a test battery? So we're not getting Apple logo with a test battery on it. Okay. Looks like we're stuck in DFU mode on that. So don't think it's battery. What I'm going to try now, I'm going to try unplugging the front face ID flex. That can sometimes be faulty and cause problems. So we're going to re-plug in the customer battery. Okay, are we getting anything on the screen now? Nothing at all. Let's try unplugging the screen. Nothing there. We should be pulling around about an amp on this at the moment. It's quite fun this, because you're getting to see more of a diagnostic than just kind of in there, pull a cap off, you know, stick it back together again. It's nice. It's more in depth. You can see a little bit more of what's going on. So not nice from a fixing point of view, because you know, not fixed yet. So let's have a little look now. We're pulling 0.3. Maybe that something else has been damaged somewhere along the line. So you know, there might be another component that needs to be looked at, tested, replaced. We're not getting the current draw that we should be getting on this at the moment. We're not getting battery. We're not getting full load on there. So yeah, we need to carry on, have a look at this. I'm going to unplug more stuff from the board and see what else the problem could be. So I'm going to unplug all of the non-necessary components first, because as far as I could see, everything else was fine on the board itself. So we're going to unplug all of those, see if it starts working after that. Unplug the power, plug it back in. Pulling 0.07, it usually shows some sort of a VBAT problem, that does, or some sort of a, it may be that U3300 has gone faulty and I have to replace that. So that kind of current reading, 0.3, I find is often U3300 related. It may be that the short has caused that component to burn out. This is quite common to get after you've had a short. So I'd say probably 1 in 50 you might get this fault occurring after you've replaced the cap. So, you know, got other things to investigate. What I'm going to do now, though, I'm going to have to probably going to have to split this board off again. So let's have a little look. Let's take everything out, and we're just going to split the board off again and see if we can get down to the bottom of the problem there, because I don't think we're getting any further with it yet. So let's just pull the board out. Let's have a little look here what's going on. Board looks like it's been put back together nicely. I don't see any problems there. Don't see any splitting. Don't see any other damage. Let's have a little look under the microscope and let's just see, make sure I've not done anything wrong along here. So I'm seeing that that's a beautiful, nice flat rejoin there. All the layers are nicely back together again. The only thing I would say I'm seeing here, you can actually see this now. I'm not happy with this corner here. This could be the source of the problem. Let me show you on this, and this can happen when you rejoin these boards. Let me show you this corner here. This is really interesting. This, see this where it's lifted here? Right there you can see it. So there you can see nice joins all the way along. That bit there, right where my tweezers are, that's lifted. I've had a close look inside it, and one of the intersperser plates where it's I don't know whether you can see it quite clearly. It's tilted sideways. That will be a potential problem because we're splitting the layers there. I don't see it causing a no boot issue. It would more likely cause a no touch issue, because that's a lot of the touch area, but it could be that something's going wrong. So what we're going to have to do, we're going to have to get our heat plate again, and we're going to have to split the boards, because that's just what you have to do when it goes wrong. So you go back in again. Let's get our thingy-majingy, our screw that we had. I won't be able to stay on with you for much longer because I do have to open the shop in a bit. Be another 5 minutes or so, but hopefully we'll get this working at the end of it. We've found the short. We're literally just having a look at getting these boards back together again, maybe having to replace U3300, and then, you know, hopefully from there we should be good to go. I can't see this going out as a no fix. This is more likely to be a fix than a no fix, this one, because we have found the source of the problem. We're just now diagnosing why this board hasn't gone together nicely. It's not bent, so I'm probably going to do this now without using the top pressure on it. I'm just going to smush the board side to side a bit. When it's heated up, I'm just going to move it side to side, try and get good connectivity again. I'll check under the, I'll check from the side view. So basically what I'll do, I'll get it there. I'll just have a little check here to make sure that it's going together nicely. Yeah, it's still raised up high there. What I might do when the boards are split now, I might just have a little check just to put some power into it, because it will boot top layer only. So, you know, let's have a little bit of a giggle. Let's see if the top layer boots. It's not quite moving yet. Not on the move yet. We're up to 186, 187. I need a drink. I've got a dry mouth. Ah, that's better. Okay, let's see if these boards are split now. Yep, we're on the move. Right, up we go again. Okay, so I'm going to put that to one side now. I'm going to pull the power on it. I'm going to put that to one side. I'm going to see if we get boot just on this top layer. I just need to cool the board down a bit first. I'm just going to put it on the heat plate there. Let it dissipate a bit of that heat into the plate. Okay, so what we're going to do now is we're going to stick this onto the screen like that. Is that genuine? Yeah, looks like a genuine screen, that one, so we're good to go. If you don't have a genuine screen, you won't get an image on these, because the power gets pulled from a different circuit on the non-genuine screens when the boards are split. So yeah, you need a genuine screen in order to test. Just plug that into there. Plug that into there. Powering on. Right. Just done that. This is really weird, this, actually. Let's just make sure, 100%. That's fine, that's fine. That's okay. Power on. Yeah, we're okay. So I thought that was a short, but my probes down here were shorting out with each other. So, right, now let's try and prompt a boot. Are we going to get Apple logo on it? We're not getting a good current draw on this. We're getting 0.076 current draw on this, so we're not getting a good current draw on this unit at the moment. Power it off, power it back on again, and prompt to boot. So we're getting 0.075 at prompt to boot on this. Could be a chance here that the U3300 chip has gone on it. That's quite a sign that it has. The problem with it is there's no way of testing, so it's a bit of a punt. You know, we just have to sit here and think, right, what's the chances of us replacing that chip and it working? So we know we've got a problem with our top layer. Let's just make sure where I chipped that cap off that I didn't leave anything behind, any remnants behind that might be shorting out. Gotta have a think about that as well. So that's where I chipped it off. Looks absolutely fine, no problems there at all. It's very delicate, so there was nothing else around that area I don't think that was disturbed. Incredibly delicate, so we are looking good around there. I can't see that being any problem. So I am looking at this one here, this chip in the corner now, being the issue. So this chip here is U3300. This often does cause problems like this. So, you know, let's go in there, let's just blindly replace it. It might not be the problem, but I can't think of anything else at the moment that might be causing this problem. So we're going to have to just go in and try and replace that cap. That IC. So a little bit more fun than usual. Let's just make sure we've got them in. I did buy a load in, so hold on. Okay, so we have these. Yes, we have plenty of them. Pack of 5. As you can see, it is quite a common one to go wrong, so I just want to check part numbers, make sure we're right. SN2501A1, yep, that's the one. Cool, right, so over this corner, we don't have a great deal. We've got the battery connector, and we've got the chip. It's not underfilled, that area, so we're not too bad. I'm going to try and go in from kind of this angle, I think, because I can get my tweezers nicely in. I need me nice sharp tweezers because I need to be able to get right in. There we are. Yeah, that's nice. I can lift that up nicely there. Let me show you now. So we're going to go back under the microscope. Boom, there we are. This is the chip that I am going in for. Now what else might be wrong is this little MOSFET here takes a hell of a beating when it takes a short. So it may be that that's gone faulty. So let's just try. Let's change this chip anyway because it's a nice easy chip to change. So we're going to go straight in there, going to get our hot air, go in at 360 on our JBC JTSE hot air station. Honestly, I don't know what yours is going to be because not many people have this hot air station because it's thousands of pounds. So let's just get this chip off. We're just going to heat it up, heat it up, heat it up. Can you see that nicely? Heat it up nicely. Okay, and then we're just going to start lifting. Move around. Okay. There we are. Straight off, straight away. Okay. Remember your orientation. It's not so bad with this one because there's a little pin missing here that kind of helps with orientation. Right, so let's stick a bit more flux on here. Bit of flux on. Then we're going to get our micro pencil and a tiny bit of solder. And we're just going to go across here and get rid of all this excess solder. Okay. Clean it all up nicely. Right, what I did notice was a tiny little bit of that jelly stuff over here next to this. There you go. I noticed that the IC got stuck to it as it was trying to come off, so I don't want that there. It'll just get in my way while I'm trying to put the new one on. Let's get some solder wick. Get some nice thin stuff. And we're just going to wick away. Wick, wick, wick. Get rid of all of the excess solder on these pads. Wicking is a bit of an art, I have to say. You'll get used to it eventually. If you're new to this, you will honestly get used to it. I know a lot of people, when they're wicking to begin with, pull a lot of pads. It's something you do get used to, and you stop pulling pads after a while. Once you get the feel of the boards, you won't do it anymore. So just have some patience with yourselves. A lot of solder left on these pins next to these caps here. There we are. Doesn't have to be perfect, you know, you're not looking for it to be a bloody award-winning. As long as they're all roughly the same height, there is a tolerance. I know it looks like there's not much of a tolerance here, but there is quite a tolerance between these pads. So let's just clean it up. We don't want all of that burnt on flux to be going where the chip's going. You'll end up in a whole world of pain if you leave all that flux there. Okay, that to me looks perfect. Nothing left behind there. The only thing I've got is a little fine wisp there that can go. I want to get rid of that because that'll end up floating under it. Now let's just get this chip on. So, like I said, you can see on this one there's a pin missing on the chip. That coincides with that little area there where there's also a pin missing, so gives you your orientation almost immediately. I'll put that chip down there. I'm going to put a tiny bit of flux on the board. It's way too much flux. I can spread a bit of that around. Take it off. Don't leave it on, take it off if you can, because you don't need that much flux. Okay, chip going into place. So, I'm going to get our hot air again now, and we're just going to float that into place. Okay, I'm going to hold it with my tweezers. Sorry, I won't be talking much now for about 30 seconds because I need to hold my breath to do this. That's a little secret that most people do. Hold on. Right, we're just reflowing it now, wait for it to move and then we'll give it a nudge. Okay, perfect. You've seen it move. You've seen it, just give it a tap. Give it a tap as long as it moves back to where it came from. Okay, let's give that a go now. Okay, clean a bit of that flux off. Not nice to leave it all behind. There's your TriStar, or Hydra as they call it now. That is so uncommon to fail. Very uncommon to see that fail these days. Right, so we're going to just get our screen again now. Let's plug this back in again. Let's get our bench power supply and switch it off first, and then we're going to just put some boot into it. Let's see what it does. So we're exactly where we were before, 0.001. Right, let's boot. Pulling 0.09 now. On prompt to boot. Let's go back to camera. Not getting anything there. I'm going to have to open the shop in a sec, because my colleagues will be here in a second. Well, you win some, you lose some. I will carry on looking at this, because I do believe this is going to be a fix. But I just need to try and hunt down what the problem is. The next job I'm going to do, I'm going to replace that little MOSFET, because that did take quite a battering. It may be that's what's gone faulty on it. So, you know, let's try replacing that. Unfortunately, not got time for you to follow me on that one, because I do need to open up. So, yeah, thanks very much. It's been interesting. And I will let you know on the next video how it went with this repair, so that at least you're up to date. So thanks very much then. Everyone have a good day. If you need repairs, www.bitrepairs.com. It's been an amazing hour with you all. Thanks very much for joining me, and have a good day. Thanks.